Welcome to WaterMission's video series on the Grundfos Renewable Solar Inverter, or RSI. This video covers WaterMission's Safe Water Project System Performance Checks. Topics include required tools and reference information, expected design performance parameters, measured performance parameters, and analysis and action steps. Before we jump into the outline, let's cover a few important pieces of information. These system performance checks are important because they ensure the project is performing as expected and can meet the required water demand of the community. These checks also help with early identification of issues that could become larger problems later on, saving time and money in the future. Prior to completing these performance checks, it is assumed that the project has been installed according to standard and has passed all installation and pre-startup inspections. The startup wizard has been completed, the pump rotation direction has been determined and set, and that the project minimum and maximum frequencies have been determined and set. If you have not completed these steps, stop here and complete them now. Check out WaterMission's other videos on these topics for more information. Finally, this video is a placeholder for a future video that will streamline and automate some of the steps in this video, but it still provides a complete walkthrough of the performance check process. First, let's look at the tools and reference information required to complete the system performance checks. Tools include a clamp multimeter that can read DC amps and a well depth finding tool. Reference materials include a completed WaterMission pump design tool, a yield test or drilling report for the project, and a manufacturer pump curve for the installed pump. Next, let's look at the expected performance values based on the project design. This table includes all of the hydraulic and electrical performance checks included in this process. The table provides the check on the left, a place for the expected value in units in the middle, and how to determine the expected value on the right. We will now go through the process of finding the expected value for each performance check parameter using the Gwandy Community Safe Water Project as an example. While the values will change throughout the day since the solar resource changes each hour, we will use the 12 noon hour assuming that the actual tests will be done during that hour. It is recommended that project staff complete this table before going to the project site for multiple hours of the day to provide flexibility, but in general it is recommended to perform the actual tests during the middle of a sunny day when the solar resource is strongest. The static water level can typically be found in the drilling report or yield test and is sometimes noted on step 3 of the PDT. In this case, it is 16.07 meters. The dynamic water level can be found either in the yield test report or in step 3 of the PDT by subtracting the dynamic water level elevation from the ground elevation at the borehole. In this case, it is 21.5 meters. The expected pressure gauge reading at the borehole discharge train when the pump is off, when the supply pipe is filled with water, can be found in step 3 of the PDT by subtracting the elevation of the pressure gauge from the elevation of the top of the storage tank. This typically then needs to be converted to PSI, which in this case is 105.25 PSI. The expected pressure gauge reading at the borehole discharge train when the pump is on can be found in step 3 of the PDT through the formula total dynamic head minus the dynamic water level minus the riser pipe pressure losses. This typically needs to be converted to PSI as well, which in this case is 88.38 PSI. The production at the hour tested can be found in step 5C of the PDT, the hourly water production, which in this case is 15.6 meters cubed per hour. The open circuit voltage for the hour tested can be found in the PDT step 5B, column J, the array VOC. In this case, it is 684 volts DC. The maximum power point voltage or operating voltage for the hour tested can be found in the PDT step 5B column K array VMPP, which is prior to degradation since the project has theoretically just been installed. In this case, we have 566 volts DC. The frequency at the hour tested can be found in the PDT step 5C column J frequency. For this project, it is 50 Hz since we have a 50 Hz pump. To find the expected combined PV current for the hour tested, first find the duty point in the PDT step 5 at the hour being tested. In our case, at 12 noon, the duty point is 15.6 meters cubed per hour at 116 meters of head. Then, using the Grundfos Product Center for the project pump, enter the duty point values to find P1. In this case, we have 9.076 kilowatts. Multiply P1 by 1.05 to account for conversion efficiency to get 9.53 kilowatts. Finally, divide the pre-degradation VMPP for the hour to get the expected PV current, which in this case is 16.83 amps. The string level PV current can be found by dividing the combined current by the number of parallel strings. This project has 3 parallel strings of solar panels, resulting in an expected string level current of 5.61 amps, as the load should be divided close to equally across the strings. And finally, the expected solar power can be found using the first 2 steps to find the expected combined current. Finding the duty point in the PDT at the hour being tested, and then finding P1 by plugging those values into the pump curve on the Grundfos Product Center. In our case, we have 9.076 kilowatts. Next, let's take a look at how to measure these system check parameters for actual performance at the project site. First, let's look at the hydraulic checks. These tests should be completed using solar power. For the static water level, test the well depth at the borehole when the pump is off with either a well depth dipper tool or the Eno Scientific Well Watch 670. For the dynamic water level, test the well depth at the borehole when the pump is on. For the discharge train pressure gauge, take a reading both when the pump is off, making sure that the water has first reached the storage tank, and then also when the pump is on. For the production at the hour tested, perform a 1-minute water test with the pump running at full speed and convert the volume to meters cubed per hour. Not only should this be compared with the expected values of the PDT for the hour tested, but also compared to the pump curve at the operating pressure. For the electrical checks, again, make sure that the system is operating on solar power only. Also, several of these checks involve working with energized equipment or from the Water Emission Grundfos RSI manual and train the operator to complete it twice daily, once in the middle of the day and once in the late afternoon. Thanks for watching this video on RSI system performance checks. Make sure to check out Water Mission's other Grundfos RSI training videos.